Welcome to the Microsoft Azure AI Fundamentals AI-901 Question Bank series. In this video, I've got 10 exam-style practice questions lined up for you, covering the kind of AI concepts and capabilities, generative AI, Microsoft Foundry, prompt engineering, and responsible AI scenarios you'll see on the real AI-901 exam. Each question comes with a correct answer and a full explanation, including why the wrong options are wrong. Here's how to get the most out of this. When a question appears, pause the video, pick your answer, then hit play to check yourself. Ready? Let's dive in. Question 31. A lightweight app built on Foundry needs to show whether each incoming customer message is positive, negative, or neutral. What should the app do? The correct answer is C. Send the message text to a deployed language model or text analysis capability and read back the sentiment result. The app sends the message text to a deployed model or text analysis capability configured for sentiment and displays the returned classification. Now, why the other options are wrong? Store the message unread in a queue indefinitely is incorrect. Simply queuing the message unread does not produce any sentiment result. Resize any image attached to the message is incorrect. Resizing an image is a vision operation and does not analyze message sentiment. Play the message as audio through a speaker is incorrect. Playing audio through a speaker does not analyze the sentiment of text. Question 32. A support ticket triage app built on Foundry needs to surface the key phrases in each ticket so agents can scan issues quickly. Which approach fits? The correct answer is D. Call a text analysis capability configured for key phrase extraction on each ticket's text and display the results. Calling a text analysis capability configured for key phrase extraction pulls out the most important terms from each ticket for agents to scan. Now, why the other options are wrong? Convert each ticket to speech and play it aloud automatically is incorrect. Converting text to speech does not extract key phrases, it produces audio. Generate a new random image for each ticket is incorrect. Generating an image does not surface key phrases from text. Ignore the ticket text and only show the timestamp is incorrect. Showing only a timestamp discards the information agents actually need. Question 33. An app lets a user speak a question directly to a deployed multimodal model that accepts audio input, and the model replies in natural language without a separate transcription step. What is happening? The correct answer is A. The multimodal model is processing the spoken audio input directly to understand and respond to the prompt. A multimodal model that accepts audio input can process spoken prompts directly, understanding and responding without requiring a separate speech-to-text step first. Now, why the other options are wrong? The audio is being silently discarded and a default answer is returned is incorrect. The scenario describes the model actually using the audio to generate a relevant response, not discarding it. The audio is being converted to a spreadsheet before any processing is incorrect. Converting audio to a spreadsheet is not a step in responding to a spoken prompt. The app is performing object detection on the audio waveform image is incorrect. Object detection applies to images of objects, not to interpreting spoken audio prompts. Question 34. Why might a developer choose a multimodal model that accepts audio directly rather than chaining a separate speech-to-text step before a text-only model? The correct answer is B. It can simplify the application by handling spoken understanding and response generation in a single model call. A multimodal model that accepts audio directly can simplify the app's architecture by handling both understanding the spoken input and generating a response in one call. Now, why the other options are wrong. It removes the need for the application to ever display text, is incorrect. The app can still display text output. Using audio input doesn't remove that option. It guarantees the response will always be in a foreign language, is incorrect. The model responds in whatever language is appropriate to the conversation, not necessarily a foreign one. It is the only way to detect objects in an image, is incorrect. Object detection in images is unrelated to why a developer would choose an audio-capable multimodal model. Question 35. A developer wants real-time streaming transcription of a live presentation within a Foundry-connected app. Which Foundry tool's capability is designed for this? The correct answer is C. Azure Speech Real-Time Speech-to-Text. Azure Speech, available as a Foundry tool, provides real-time speech-to-text for streaming live transcription scenarios. Now, why the other options are wrong? Image generation model is incorrect. An image generation model creates images and does not transcribe audio. Key phrase extraction is incorrect. Key phrase extraction operates on text that already exists. It doesn't transcribe live speech. Content Understanding Document Analyzer is incorrect. A Content Understanding Document Analyzer processes documents and forms, not live audio streams. Question 36. A Foundry-connected app needs to read an agent's text responses aloud to users in a natural voice. Which capability should the app call? The correct answer is D. Azure Speech Text-to-Speech. Azure Speech Text-to-Speech converts the agent's written response into natural-sounding spoken audio. Now, why the other options are wrong? Content Understanding Video Analyzer is incorrect. A video analyzer extracts information from video content, not from an agent's text reply. Object detection is incorrect. Object detection locates items in images and does not produce audio. Entity recognition is incorrect. Entity recognition identifies named items in text and does not generate spoken audio. Question 37. A company wants its Foundry-based app to speak responses in a consistent, branded voice across every customer touchpoint. Which Azure Speech capability supports this? The correct answer is A. Custom Neural Voice. Custom Neural Voice lets an organization create a distinctive, branded, synthetic voice used consistently across its applications. Now, why the other options are wrong? Key phrase extraction is incorrect. Key phrase extraction pulls terms from text and does not affect the voice used for audio output. Language detection is incorrect. Language detection identifies which language text is written in. It does not shape how audio sounds. Object detection is incorrect. Object detection is a computer vision capability and is unrelated to voice branding. Question 38. An inspector uploads a photo of a machine part and asks in text, "Is there visible corrosion here?" to a deployed multimodal model. What is this an example of? The correct answer is B. Interpreting visual input in a prompt by using a deployed multimodal model. Sending an image along with a text question to a deployed multimodal model, which then interprets the visual content, is exactly this scenario. Now, why the other options are wrong? Converting the photo into a spreadsheet of pixel values for manual review is incorrect. Manually reviewing pixel values in a spreadsheet is not how a multimodal model interprets an image. Encrypting the photo before it is deleted is incorrect. Encrypting and deleting the photo would prevent it from being analyzed at all. Training a brand new model from scratch is incorrect. The scenario uses an already deployed model. It does not involve training a new one from scratch. Question 39. A finance app lets a user upload a photo of a printed chart and ask, "What was the highest value shown?" A multimodal model answers correctly. What capability made this possible? The correct answer is C. The model interpreting both the image and the accompanying text question together. The multimodal model interprets the visual content of the chart together with the text question to produce a grounded answer. Now, why the other options are wrong. The model converting the chart into an audio podcast first is incorrect. Converting to a podcast is unnecessary and not how the model interprets a chart image. The model deleting the chart image before answering is incorrect. Deleting the image before analysis would make it impossible to answer the question. The model randomly guessing a plausible number is incorrect. The model reasons over the actual visual content rather than guessing randomly. Question 40. A marketing team wants to generate several brand new hero images for a campaign from short text descriptions using Foundry. Which capability should they use? The correct answer is D, an image generation model deployed in Foundry. An image generation model deployed in Foundry can create new original images from text descriptions. Now, why the other options are wrong? A key phrase extraction capability is incorrect. Key phrase extraction operates on text and does not produce images. A speech-to-text model is incorrect. A speech-to-text model transcribes audio and cannot generate images. A regression model is incorrect. A regression model predicts numeric values and has no ability to generate images. And that's a wrap on this video. Nice work getting through those 10 questions. If this helped, you're going to want the complete set, all 300 exam-style questions, with full explanations across both AI-901 skill areas, are available in my Udemy course, Microsoft Azure AI Fundamentals, AI-901, 6 practice exams. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 10 more questions. See you in the next video.